Hello guys, how's it going? This is my tier list for every single topic that I've studied so far in computer science. So a little bit of background here. I am a third year computer science student at the University of Minnesota. So now that I've doxed myself, none of you can dox me. Second, even though I'm just a third year, I'm a little bit ahead of my schedule, so that has allowed me to study quite a bit of topics over a year. So all these are ordered currently based on which one I took first. So let's go from there. Um, so this tier list is about how fun they are, not how useful they are, and because of based on how fun it is to me, it's obviously subjective. So feel free to disagree. This is just how fun I find these subjects. Let's start with calculus. I'm gonna give it a C. So calculus is obviously very useful, especially in the upper division classes. Um, if you're starting out in computer science and you have to study calculus, and you might wonder, oh, like, why are we even doing this? This seems irrelevant. Oh boy, it's gonna be relevant if you really want into to go into stuff like machine learning or network or stuff like that. Calculus is absolutely necessary, but as a subject, it's painful. It's not painful, but it's like it's pretty boring. Like it's pretty boring, right? Like I always thought I was a math person, but like college calculus, yeah, pretty boring. Okay, intro to program development. This was just a coding class. It's a class that gets you into coding in Python and Java, and also teaches you object-oriented programming. I'm give it an A. It was quite pleasant to do. I had a very good professor. Python is very easy, and Java is I actually don't have anything good to say about it. So um, honestly, if not for Java, it would have been S. But there you go. Discrete mathematics. This one is a bit difficult. Discrete math itself is not as boring as all the math, but there's a lot of proof and it's quite challenging if you are not used to grinding proof and have never done that before in your life. It starts out quite slow, so you're gonna do logic and or exclusive or stuff like that, and then you go into set theories. You do permutation combination, and then you grind a lot of proof. I'm gonna give it a B. It was decently easy to me. Um, I did have spent a bit of effort on it, and it's definitely to me is more fun than calculus. But it's still math, so there you go. Linear algebra, also gonna give it a B. I took both of these classes with the same professor, and I was pleasantly surprised by how um, enjoyable linear algebra really is. You study matrices, matrix operation, linear equations, because the professor also teach discrete math. He throw in some proof over there, which was not as enjoyable. But you end up learning a lot. You end up learning a lot about how stuff work in linear algebra and not just memorizing equations and doing homework. So yeah, also linear algebra is so important in computer science, especially in data science fields. So if you really want to do like stuff like machine learning, um, pay attention in this class. Like do yourself a favor and just pay attention in this particular class. Advanced programming principle S tier. Yeah. By advanced programming principle is just recursion and functional programming. We use this language OCaml that like 10 people, total of 10 people uses in the entire world, and this class is very boring. It was not difficult. It's just so boring, and I feel like I learned nothing from it at all. except for recursion, and I don't even use recursion a lot. Recursion is good for traversing trees, which is relevant for this class. But let's move on to machine architecture. Easily S tier. So I am surprisingly really into low-level programming. This class was taught in C, and you interact very closely with computer memories and whatnot. So it comes with a lot of like difficult tasks such as malloc-free, watch out for memory leaks. We did learn a lot about how a computer actually work. Not a computer yet, more so like a machine. So CPU, RAM. We did have an assembly language portion, which I didn't really enjoy. But this class was very enjoyable. I feel like I learned a bunch from this class. Um, Algorithm and data structure. Give it a B. Yeah. So there's no programming in this class. So if you like, say, you're a very good programmer and you really like writing code, um, this class might not be for you, but you have to do it anyways because algorithm and data structure is very important. It is a math class, so you will learn about trees, binary trees, algorithm to traverse that trees, graph graph traversing algorithms. So to name a couple of stuff that I learned off my head, there's sort algorithm such as heap sort, quick sort, graph traversing algorithms such as Dijkstra, BFS, DFS. We did not learn A star. Yeah, I don't think we covered A star. But you once you got a solid foundation in algorithm and data structures, it gets easier for you when you learn all the classes in the upper division. So make sure you get a pretty good foundation on this class. As I say this based on how fun they are, not how useful they are. All of them, I think, except for this one, but all of them are very important if you want to succeed as a computer science student or just a computer scientist in general. Statistic. Plug in C. Very important class. Extremely boring. It's not painfully boring, but it's very boring. I don't think there's not much. I don't think there's much to say about statistic, other than there's a lot of equations and methods, and you just plug numbers into your TI-84, and stuff will work out for you. It's not particularly interesting or challenging. It's just something that you need to know. OS. Let's do S tier. As I've said, I'm a huge fan of low-level programming, so this is it. This comes naturally. We learn about processes, um, how to communicate between processes via pipe, signals, and we did touch a bit on how the internet actually work. So this class was absolutely needed for the next one that I took down here, internet programming, but we talk about later. Let's talk about software development. I'm gonna give it an A. So software development, you can see I have a software engineering class here, and you might wonder, oh, what is the difference? Honestly, I do not even know anymore. Both of these classes cover like very similar materials, but they approach them differently. In software development, we were introduced to Git, and we use GitHub for most of the classes. We work on a very big project from the beginning of the year until the end of the semester. So there's design patterns that we learn. Oh, we also learn about UML diagrams, how to draw UML diagrams, design patterns such as strategy pattern, um, decorator pattern, stuff like that, facade pattern. There's a bunch of patterns that I can't remember off the top of my head because there's just so many of them. But it's very useful, and most of us, right? Most of us, after we graduate as a computer science student, a huge chunk of us will go into software development. So might as well just pick up the necessary skill here. Internet programming, I'm given S. Really enjoy it. I know I picked the icon like HTML, JavaScript, CSS. That's not that's part of what internet programming is, but it's not all of them. We also go into how requests work, HTTP protocols, um, and right now we're doing database management, so a little bit of SQL in there. Yeah, I pronounce it SQL, not SQL. Like kill me. Machine learning. I'm gonna give it a B. Let's do a C. This class was very boring. I know it's all the hype nowadays. With ChatGPT and whatnot, AI, machine learning. Machine learning is essentially just a lot of math. Um, and this class really tested me if I was paying attention in calculus and linear algebra. I did not. Well, I did a little bit, but by the time I take this class, it's been like a year passed since I took linear algebra and a year and a half passed since I took calculus. So it was not as solid as I remember. So it took a lot of getting used to, and it was really boring. You did learn about some interesting stuff, such as some machine learning models. They learn about perceptual learning, K-nearest neighbor. You learn about clustering. There's classification and linear regression. So yeah, it's a whole mix of linear algebra, calculus, and statistic, which um, if you are not really good at math, maybe machine learning is not for you. But maybe you can push through. It's the sheer force of wanting to learn something cool make you push through all the boring math. Then yeah, go ahead and do it. Personally, I think that it's not that great in terms of fun. Move on to robotic systems. I'm gonna give it a solid A. So this class also has a lot of math. We also did not work with real robots. We work with simulation, which is totally understandable because programming a robot is very tricky, and if you are not careful, you don't have a lot of experience on it, you might break the thing. I mean, in a simulation, you can always reset and redo, but a real robotic arm, like there's a lot at stake. You know how expensive all these things are. But we did work with a simulation, and we covered topics such as manipulation, so a robotic arm interacting with other objects in the room. We did deal with forward kinematics, which is moving each of these um, link. We call them link. Each of these like part of the body of the robot. From the base, that's forward kinematics, inverse kinematics, which is given a location in the 3D three-dimensional our three-dimensional world. So given its coordinate, we need to find a position for the robot to reach that. So it's basically calculating from the end effector, which is the hand of the robot, back down to the base. And guess what we do for that? Math, a lot of math. There's for inverse kinematics is something called Jacobian, which is a 6 times n matrix, in which n is the number of links from base to an effector, and yeah, it's a lot of math. And for joints, there's something called quaternion, which deals with imaginary number. So if you really want to do robotics as well, make sure you pay attention in math classes, especially calculus and linear algebra. Okay, and on to the last topic that I was studying this semester, software engineering. I'm gonna give this on a C, to be honest. Um, you might be wondering, hey, why did I put software development on A and software engineering on C? You thought it was the same thing. It's honestly, it covers the same topic, just very different approach. And I think the approach to a class, like how the professor approached a class to teach it, is really matters on how fun the class is. And software engineering, there was just a lot of grinding and very few coding. We were grinding design documents, um, requirement specification, detailed design, and then we had to review those documents throughout the entire year. And then just now we were able to code our first program, um, and the coding was fun. But along the coding, we also have to write test reports, and we also have to adjust our specification and design document. So it was just a lot of work and a lot of grinding. And what really sucks about it is that that class does not even count as a grinding intensive class. So I feel like I was robbed of a intensive credit. That just might just be me being petty. Software engineering C tier, to be honest. So yeah, this is all the topics I've learned in college so far as a computer science student, and this is how much fun I think they are. My personal opinion. Feel free to disagree. Um, that's pretty much it. Thanks for watching.